So what questions do we have from our practice exam?
Number 4.
Sure, question number 4.
Number 9.
Number 9 as well. Which one, 23? 22, okay.
18.
18 as well. 19. And 20 also. Okay. Is that going to take care of most of those questions? Remember, I always have things worked out in Canvas as well. So I did post the worked out key in Canvas in the assignments and the announcements where you can see that. But I know sometimes you want to see how they're actually done. So we'll work through these so you can see how they're done step by step. And these questions are going to be very, very similar to what you're going to see on your exam. A little bit different, but very, very similar. What about your homework last week from Chapter 2? Let's start with 2.1. So do we have some questions out of 2.1? And that was just solving those. Okay, which one? 13, sure. Yep, no problem. Okay. 2.1, did we have any questions on those equations? Okay, what about 2.2? Did we have some questions out of 2.2? Sure, 19 and 20. Okay, 7 and 16 as well. Okay, 4 and 12 here. Yep, 16's already on there. Sure. Is that going to be it for 2.2 then? Okay. Sure, which ones were 2.1?
18.
Okay, 18 and 20, sure. What about 2, 3, and 4?
I'm gonna be like transparent with that one. Like I really needed help in like 7 years and 20 on that. I struggled.
On which one? 2.2? Okay. Yeah. Which one's on 2.1 or 2.2? Yeah, we can just go over some of them. Which ones though?
So, I mean, I stopped at 6. Like I got the basic concepts of that, but I really struggled with this one, so I don't know why.
Okay, in 2.1 or 2.2?
It's the 2, 3, and 2, 4.
Okay. Okay. Yep. Okay. And which one you stopped after?
I stopped at 6 basically, but I figured if we went over a couple,
Yeah.
maybe it would help me finish that. That's okay.
Yeah. So we'll cover several of those. Does anyone have any specific ones, or I can just add some? Uh huh.
Like 4,
Sure. Sure.
5, 11, 12, and 14.
5, 11, 12, and 14. Sure. And if we need to, we can spend more time next week going over more of these. So if we spend too much time going over these problems, we can pick up some more of them next week. Because I want to make sure we have plenty of time for our exam. Are there any others out of 2, 3, and 4 we need to add in?
2, 3, 2, 4. 7.
7? Sure. Which other ones?
Number 6 and number 16.
6 and 16, sure. And 19. And whichever ones we don't finish today, we'll cover those next week. Because I want to make sure we have at least an hour and a half for your exam today.
I just kind of figured if we went over a couple of them,
Yeah.
I could knock them out. I got, like I said, up to 6. But
Yeah, and some of the ones with the fractions, that's probably where we're stuck at, is how to clear the fractions, and maybe some of the decimal ones also. So yes, we can go over more of them next week. We'll get through a lot of these today, but if we start running out of time, then we'll just have a refresher next week. So. All right, so let's begin with questions on our practice exam, and we'll begin now with question number 4. And question number 4, on your practice exam, they give you this equation. And then they give you some possible choices. So minus 20 is a possible choice, minus 14, negative 8, 0, 8, 14, and 20. So those are my possible choices. Okay, we can look at this and we can kind of figure out which ones it's going to be. We have to watch our signs. Well, we can get rid of 20, right? We can get rid of both 20s. Why? Well, either one we put them in, it's definitely not going to give you what? 8. So 20 and negative 20 are gone. What about 8? Not going to work. Because 8 plus that 6 is definitely not 8. So those don't work. Okay, 0 is not going to work either. So we're left with 14 and negative 14. So which one is going to be our answer? Well, let's check and see. Watch that negative sign there. So let's start with x equaling a negative 14. We're going to plug it in, and we're going to see what it gives us for our final answer. Now, whenever there's a negative, we bring it down. Whenever your variable is negative, we need to put parentheses around it. Okay? Now, what's going to happen with the double negatives here? Well, the double negatives here are going to make this then what? Positive. And then we've got 14 plus 6. And does that equal a negative 8? No, because 20 definitely does not equal what? Negative 8. So that one doesn't work. So negative 14 doesn't work. Now, what about positive 14? I think positive 14 is going to work. Because if we check positive 14, we get minus 14 plus 6 equals a minus 8, right? And minus 14 plus 6, well, that's a negative 8. The sides match, so our answer should be x equals what now? X equals a positive 14. So be very careful with those double negatives there. Because when you put a negative in, you put parentheses around it, and if there's a negative out front, it just comes along with it. Question 9. Question 9, we've got a square, and we're going to go through the same type of procedure that we did a moment ago, where we plug the variables in. So we've got 3x minus 4y squared, and we need to plug in x equals 3 and y equals a negative 4. So we'll go ahead now and plug in our variables. And this is where students may make a mistake. May make a mistake with the signs. Now notice when I plugged in that y equals a negative 4, notice I put parentheses around it, right? Okay. Now, order of operations says before we multiply, what do we do first? Parentheses and exponents after that. So we need to work with this exponent here. And so what we've got is we've got minus 4 squared with the parentheses. And what that is with the parentheses is that's actually negative 4 times negative 4. And that then makes it a positive 16. Because a negative times a negative is a positive there. So we do our exponent first. And that makes that positive. The negative 4 just comes down. And now we just multiply and then subtract. So 3 times 3 is our 9 there. Then we've got 4 times 16. Which should be that 64. Right? And 9 minus 64. 64 is a larger number. It's negative. So 64 minus that 9 should make it a negative 55 there. And that's going to be your final result. So whenever you plug in a negative, use parentheses around it. Whenever it's taken to a power with parentheses like this, what do? We write it over the side, write it out twice, and multiply. Okay, so that negative times that negative is going to make that positive. And then we plug it back in, and then we do our multiplication. And then we combine like terms together. So that was question number 9. Is everyone okay with that? Because there's going to be one very, very similar to that on your exam today. Just basically different numbers in a different order. Okay, so next we're going to look at question 13. And for question 13, there's different ways of working through this one. I'm going to make a table. And then I'm going to combine all of our terms together. Now, when we read 13, we're looking at the baseball games. And we're looking at either you win or you lose. So when we talk about losing, it's going to be a negative number. And then we're going to take each game times the number of runs that we want run by. And then we'll put them together. And again, if they're a win, they're positive. If they're a loss, they are negative. So we're going to make a column for games and a column for number of runs. So we're going to take our time, and again, if you win, they're positive. If you lose, they're negative. So a baseball team won 3 of its games by 5 runs. So they won 3 games by 5 runs. That makes my total then 15. They lost 3 games by 4 runs. So since you're lost, it's going to be a negative. Since they lost, and they lost 3 games by 4 runs, so that makes that a negative 12 on that piece. They lost 1 game by 7 runs, so that's going to be minus 1. 7 runs, that makes that then a negative 7. And then they finished the season by winning 4 games by 3 runs. And that makes it 4 times 3, which is then 12. Okay, so is everyone okay with that? Everyone see how I made that table? I think that's the easiest way to do it. And you just multiply across. And now we can just add them up. Okay, when we add them up, it's going to be easy because we have a positive 12 and a negative 12, and those can simply cancel out. And then we've got 15 minus 7. Okay? And 15 minus 7, 15 is a larger number. We're subtracting them, so that's going to be a difference of 8. And that means we finished the game, or finished the season, ahead by 8 runs. So we made a table. Games, runs, multiplied them together. If you won, it's positive. If you lost, it's negative. And we added them up. And again, we know that 12 and negative 12 are inverses, so they canceled out. You could do it without a table, but I think the table makes it easier to keep track of things. 18 is the fraction one. And we want to keep the mixed fractions. We don't use mixed fractions a lot, but we're going to go ahead and keep the mixed fractions on this one. And there's different ways of handling it. One way would be to turn this all into improper fractions and combine them together. That's one way of doing it. I think the easier way, though, is to just, in this case, work with the mixed fractions. So we're going to take these mixed fractions and we're going to split them out into the fractional part and the whole part. So this minus 3/5 is a minus 3 minus 3/5, right? If we put them together, that's what that is. This 6 and 1/7 is 6 and a positive 1/7. So I took it and I split it out. Now that way we don't make a mistake with the signs. Next, we're going to go ahead and work with the whole numbers. So over to the side, we're going to work with our whole numbers first. And what do we have for the whole numbers? Well, for the whole numbers, we have a minus 3 and a positive 6. So minus 3 plus 6, that makes it then a what? Makes that then a 3. Is everyone okay with that so far? You see how I split it out? Okay, so we're looking at the whole part first, so these go together. Next, we'll look at the fractions. So what do we have for the fractions here? Well, for the fractions, we have a minus 3/5 and a positive 1/7. We're going to combine these together, so we need a least common denominator, don't we? So the least common denominator of 5 and 7 is what? 35. Okay. So that means we're going to use a 35 here. So the first one needs a 7/7. And the second one needs a 5/5. So now we have a minus 21/35 plus 5/35. And that's going to leave us then with what? A negative 16/35, isn't it? Yep, negative 16/35. Okay, so I'll slow down a minute for you to catch up, because this is one of the questions that students struggle with more than the others, and we really don't use a lot of mixed fractions, but I thought it was still good for us to go over. So when we came up with these mixed fractions, I took the mixed fractions here and I split them up into the whole part and the fractional part for each one. Then I did my whole part, then I did my fractions. Now, we need to combine these together into one mixed fraction. So we need to borrow from that 3. And we're going to borrow 1 from that 3. And that 1, when we borrow it, so we'll borrow 1 from it, so that's going to make it 2. And we're going to borrow 1, which is just a 35/35. Right? Because 35/35 is what? 1, right? So we take that 3, we're going to borrow 1 from it. And that's 35/35. Same denominator here. So that's what you want. Now we're almost finished. So now we can finish it out. And we've got 35 minus that 16. That makes it 19/35. And the 2 comes down with it, right? Because those combine together to give you that 19/35. They have the same signs, so they can go together. And then your final answer is going to be 2 and 19/35. And there's lots of different ways of working this one out. You could turn them into improper fractions and put them together that way, and then make it a mixed fraction at the end. You can break them down like I did here. I think this is the best way and easiest way to understand these. Now, why I broke these fractions up, the mixed fractions into the 2 parts, is students make a mistake here with the signs on the 3/5. And they want to add it to that 1/7. And it's not, because it's subtracted off. Okay, so that's going to give you your final answer there of 2 and 19/35. So does everyone kind of see how that works? Let's do another one, just to make sure, another example. And if we don't have a lot of time for the questions out of Chapter 2, that's fine. We can go over them next week. But we need to make sure that we know how to do this type of question on your exam. So here's another example. So we'll do this one. This one's going to be pretty easy to work through. Well, let's not make that 3/4. Let me flip these around. Sorry, that way it looks right. That's going to be 3/4, not 4/3. Sorry about that. So make that 3/4. Let's write it backwards. Okay, so we've got 8 4/9 minus 7 3/4. So same procedure. We're going to split these up. And that's 8 plus our 4/9. Splitting this one up, now it is negative, so that's going to make it a minus 7 minus 3/4 then. Split that mixed fraction up into the parts. And now let's look at the whole numbers. And what do we have for the whole numbers? We got 8 minus 7. And 8 minus 7 is a 1. And what about the fractions? Well, for the fractions, we've got 4/9. It's positive. Minus 3/4. The least common denominator of 9 and 4 is going to be what? Can someone tell me? The least common denominator of 9 and 4 would be what? 36. So we're going to go ahead and combine these together now. So we'll take this 4/9. We're going to multiply it by 4/4. And the 3/4, we'll multiply that by 9/9. That leaves us then with 16/36 minus 9 times 3, that's a 27/36. We can now put those together. And that's going to be what? Negative 11, isn't it? We've got 27 minus that 16. Yep, that's going to come out to be a minus 11/36. Is everyone okay with that so far? Now, we need to borrow from that 1. What is 1? 1 can be written as what? 36 over what? 36, right? Okay, because that's what 1 is. We can't borrow from it. As if it was 3 or 4, we could borrow from it, but in this case we can't. But 1 is what? This is 1 here, right? It's the same thing. So we're going to write that as 36 over 36. And now we can put those together. And we've got 36 minus that 11. That makes it then 25 over 36. And that's going to be your final answer there. Are we okay now with the mixed fractions, or do we need to do another one? Do you want another one? Are we do another one?
So that negative 11 over 36.
Right.
If we were going to subtract when you do 36 over 36.
Right, because that's the same thing as 1, right? Yep. And then these have the same denominators, so then we just subtract across, and that gives us the 25. Okay? But let's do another one just to make sure, because there's going to be one just like this on your exam today. Different numbers is all it is. So let's try another example. And I want us to do well, so that's why we're going to work through a lot of these if we need to. And let's work with this one. How about we look at minus 12 and 3/4 minus 5 and 2/5. Okay, so let's look at this one. So we're going to go ahead and combine all these together. Let's see what we've got. Okay, so when we split this up, we've got these here. This one's a little bit different too, but it's going to be done the same way. What's different here? Well, these numbers are all negative, so they're going to combine together. So for the whole numbers, we have minus 12, minus 5. That makes it then a minus 17. Okay, is everyone okay with that so far? Now, what about the fractions? These are both negative, so they can also be added together. We need our common denominator. And the least common denominator of 5 and 4. Well, that least common denominator here is going to be 20, isn't it? So that takes care of that piece. Now we're going to go ahead and combine these together. So this needs a 5/5 here. This one needs a 4 over 4. Combining those together, that's then a minus 15 over 20 minus 8 over 20. And putting them together, that's going to make that a minus 23 over 20, isn't it? Okay. Is everyone okay with this so far? Now we do need to go ahead and make this a mixed fraction, right? Because why is it going to be, this is an improper one right now. Okay? We want mixed fractions on these. So why is this an improper fraction? Well, it's improper because the top half is larger than what? The bottom half, right? Okay, so how would I convert this into an improper fraction? Well, an improper fraction, we know that from let me say it correctly. From this improper fraction, we want to make it a mixed fraction. So from this improper fraction, we know it's improper because the top half is larger than the bottom half. Well, we need to go ahead and break this into a mixed fraction. So it's 1 times larger, so that's going to be 1. And it's still negative, and 3 over 20. Now, how did I come up with 1 and the 3 over 20? Well, this one is larger, right? The top half is larger than the bottom half. And what's 23 minus 20? Well, that is a what? 3. So that's why it's a 3 there. Because you need to make sure you turn it back into a mixed fraction. If the top half is larger, what you do is you just subtract it from the bottom half, and that gives you that. Now, what can we do? And I don't think the one in your exam is going to make you do it this way. It's going to be like the other two we did today. But now we can finish it because what do we know here? These are both negative, so they go together. So my final answer would then be negative 18 and 3/20. Because there's no fractions to worry about. We don't have to subtract them. We don't have to borrow because these are the same signs and they simply add together. So we've got our whole part. We've got our fractional part. We then had to turn our answer back into a mixed fraction, which we did here, from the improper one to the mixed fraction. Then we rewrote it. These were the same, so we didn't have to borrow because the 17 and the 1 have the same signs, so they just go together. That makes that negative 18, and since they're the same signs, that 3 over 20 just comes down. The one in your exam is going to be similar to the first two that we just did. Does that kind of make sense how we did that? We had to borrow from it and work from there. Yes, students always struggle with mixed fractions. Mixed fractions are out there because any type of construction work has mixed fractions. When you start building any type of project, you'll be dealing with fractions, mixed fractions. And cooking recipes, all of those have mixed fractions in them. And sometimes you have to combine them together. All right, so there's that one. Hopefully we have enough examples of that now. And that was question, I think it was it. Yep, 18. So now we'll move on and we'll look at 19. So question 19. We've got 11x plus 3 over 20 minus 2y. And we've got x equals 5 and y equals 9, right? So that's what we've got. We're going to plug our values in, and we're going to break it down. So be careful when you plug them in. These are all positive, so it's actually going to be a little bit easier here. We're going to plug our values in. This is what we've got. We're going to break it up. We're going to do the top half or the numerator first. And so when I work out a fraction like this, what I always do is I kind of split my paper in half, and I work out the numerator write it down, denominator, write it down, and then put them together. To be successful in mathematics, you want to be organized. Because if you're not organized, you'll forget what pieces go where, and you'll make a mistake and get frustrated. So always take your time. I always like to split my paper in half. That way we've got one side that's clean that we can read and follow through on. So on the numerator, we have 11 times 5 plus 3. So that is 55 plus 3. And that makes that numerator then 58. We repeat the process with the denominator. And we've got 20 minus 2 times 9. So that's 20 minus 18. And 20 minus 18, that's going to make that then a 2, isn't it? And now we've got 58 divided by 2. And that's going to be, what, 26, I believe, isn't it? 58 divided by 2. Always use a calculator if you're not good at mental math. Sorry about that. It's going to be 29, not 26. You should always use a calculator to double check things. That way you don't make a mistake. 58 divided by 2 makes it then your 29. Is everyone okay with how I did that? And don't ever feel like you can't use a calculator. I would rather use a calculator than make a mistake. Okay, question 20. For question 20, we need to turn this into an expression. So when we talk about expressions, do we have an equal sign with expressions? No. We have an equal sign with equations, not expressions. So we're not going to have an equal sign here. So it says, write the following phrase in symbols and then simplify the expression. So let's talk about what we've got. We're going to read it through once, and then we're going to talk about each word and what it means. So the quotient of 7 and the sum of 21 minus 8. So when we talk about quotient, what does quotient mean? Quotient means divide, right? So what are we going to do here? We're going to take 7, and we're going to divide that 7 by what? By the sum of 21 minus 4. And then we can break this down a bit. So 7 stays in the numerator. And then 21 minus 4, well, that makes it a 17, doesn't it? Yep, so that's going to be a positive 17 below. And then what's our final answer going to be? Our final answer is going to be 7 over 17. Is everyone okay with how I did that? So quotient means divide. We're going to divide it by those two numbers added together. Oh, wait, no. Did I read it wrong? Yeah, it should be an 8, not a 4. My mistake there. Sorry about that. I read it wrong. So 21 minus 8, that was my mistake there. Okay, so 21 minus 8, yep, that's going to be a 13. Sorry about that. So that should be a 13 over 17. Yeah, it was just hard to read with the face shield on. But is everyone okay with how I set that up and worked it through? Okay, so don't miss this one. This is an easy one. This is much easier than the mixed fraction one, so hopefully everyone can get this one correct. There's not a lot to it. Take your time, read it through, figure out what pieces go where, and then follow the directions. The last one that we asked about was question 22. And for question 22, we've got square brackets and we've got parentheses. Now, square brackets are going to work the same as parentheses. So they behave the same way. We use square brackets when we've already got parentheses in the problem. So we've got square brackets because parentheses are already used. Now what we do on this type of problem is we follow order of operations, and we're going to work on the inside and we're going to work our way out. So we work on the inside and we work our way out. So the first thing we look at is we look at this set of parentheses. We're going to do the inside and just slowly work our way out. And that first set that I've got underlined is 20 minus 11. Well, 20 minus 11 is a 9. So that gave us the 9 there. Now we can work on this part. Minus 20 plus 9. Well, the 20 is larger, it's negative. So we're going to subtract them. And 20 minus 9, that makes it an 11. And so it's going to be a negative 11. This negative here just comes down. A moment ago, we talked about how square brackets and parentheses are the same, right? So if we had parentheses, we would be able to cancel out the double negatives. We can do the same with the square brackets. So the double negatives at that 11 are going to make that then a positive 11. And now we can finish it out because we've got negative 7 plus 11. 11's larger. 11 is positive. So my answer is positive. And what's 11 minus 7? Well, 11 minus 7 is going to be a 4. So your answer on that one is going to be 4. Is everyone okay with how I did that, though? Do you see how I took my time and I worked on the inside and just worked my way out? We've got some time left. We're going to go over several questions out of Chapter 2. We may not get to 2, 3, and 4 questions, but we'll at least finish up 2, 1, and 2, 2 questions of it. And we might get to some of them out of 2, 3, and 4. But if we don't, we'll cover them next week. Because I just want to make sure we have plenty of time to take our test today. So again, whatever we don't cover out of 2, 3, and 4, we'll cover then next week. Okay, so we'll get set up here. And we're going to look on 2.1, we're going to look at question 18 first. Get this set here. So 2.1, we're going to begin with question 18. This is on the back page. Okay, and this is a fraction one. So we've got 1/4 x minus 8 equals a minus 3/4 x. I'm sure we asked about this one because of the fractions. Now, we can either clear out the fractions, or in this case, it's going to be easier if we just combine them together. Because when we look at this, we could clear them out. But when we look at this one, what do we notice about these denominators? They're the same, right? So we don't necessarily have to clear them out. It's probably going to be easier if we just add them together. So our goal is to get the x on the left, numbers on the right. So this 3/4 is negative. So I'm going to add on to both sides a 3/4 x. Now again, we could have cleared the fractions, but that would have been a lot of extra steps. And since these have the same denominators, just put them together.
It is okay that I did it with the 8 though instead. That's how I did mine, was like a positive 8 and then a positive 8.
Oh yeah, you can move that over that way and then move them over. Yep, either way. Our goal, and however you want to move them over, is just to make sure eventually that my variable's on the left, numbers are on the right. So if you want to move that 8 over and then move the x over, you can do that too. Either way. It doesn't matter because you get the same result. So I went ahead and moved that 3/4 over, right? And that's going to be addition here because the opposite in signs. 1/4 and 3/4, well, that makes it a whole 1. So those are going to go together, and that's going to make that then an x. On the right-hand side, these are going to cancel out. And that leaves you then with the 0 on the right. Now we need to go ahead and get the x by itself. And when we move things across the equal bar, they switch signs. So this -8 needs to go over. So we'll add it. And then that leaves us now with x equaling what? +8. Bless you. Question 20 is very, very similar. They're all kind of the same. They use the same principle, just different numbers here. So question 20, we've got 1/4 x minus 1 equals a minus 3/4 x. A lot of this is just repetition and doing the same thing over and over again. A lot of mathematics is just remembering the order and repetition. So we need to go ahead and get the x on the left. So I'm going to add the 3/4 x over. And then again, we know that 1/4 and 3/4, those go together and make it 1. On the right-hand side, these are going to do what? They're opposites. And when you put them together, they make it a 0. And what's our last step going to be? We're going to do the same process as the previous question. To move that 1 over, what do? We simply add 1. And so then what's our answer going to be then? X equals 1. And these will get a lot easier. Once you do a lot of them, it'll be almost second nature. So by the time you get to college algebra, you'll be able to solve these with no problems at all. Right now we're learning how to solve them, and that's okay, but we're going to get a lot better at them. We're going to get a lot quicker at them too. 2.2, we've got a lot of questions. And we're going to begin with question 4. Some of these have fractions. Some of them are whole numbers to work with. Question 4 is a fraction problem. On this question, I would recommend that we clear out the fractions. On the previous one, we didn't necessarily need to clear out the fractions because those had the same denominator, right? And we could have cleared them out, but that would have been an extra step. And these went together nicely. But what do you notice here? Right? These are all different, aren't they? So it's going to be easier if we clear them out at the beginning. If they're all the same, put them together. If they're all different, I recommend clearing them out. So we need a number that's going to go into all 3 of those numerators. So let's begin with the first 2. Okay, what's the least common denominator of 3 and 6? 6. Okay, I like to do them 2 at a time. I like to work with pairs. So our least common denominator of those 2 fractions is a 6. Now we're going to take that 6, and what's the least common denominator of 6 and 9? Can someone tell me what that would be? 18. Is everyone okay with how I got that 18? So now we know that we need to multiply everything by 18. because 18 is our least common denominator. And I like to write it out front and draw my arrows. Now, how do we clear these fractions? What do? We divide by the number down below, multiply by the number on the top. So 18 divided by 3. 18 divided by 3 is going to be your 6. And 6 times 1, that makes it 6. And we're going to bring down the x with it. Next, 18 divided by 6. Well, 18 divided by 6 is a 3. 3 times 1 makes it a 3. Bring down the x. Next, 18 divided by 9. Well, 18 divided by 9 is 2. Times that 1 makes it a 2. Bring down your x. And don't forget about the right-hand side. 18 times 22. We'll need a calculator here. But 18 times your 22 is 396. Now we can finish it because these can go together. So we'll go ahead and add these up. So we got 6 and 3, that makes it 9, plus 2 more makes it 11x, and that equals 396. And now we're going to go ahead and divide both sides by 11, because that gets rid of it. And 396 divided by 11, well, that comes out evenly to be a 36. And we could have combined the fractions together, but I think it's easier if we just clear them out at the beginning. When the denominators are different, clear them out. If they're the same, just put them together. Question 7. Again, this is another fractional problem, and we're going to approach it the same way. So question 7, we've got 2/7 x plus 1 over 14x plus 2 over 21x, and that equals 38. So let's go ahead and work with our fractions. The least common denominator of 7 and 14 is a 14. The least common denominator of 14 and 21 is going to be what? Well, if we struggle finding denominators, what do? We take the larger number. What's the larger number? 21. It's 21 divided by 14. No. Okay? So then we double it. 21 times 2, well, that's what? 42. Does 42 divide by 14? Yes. So what's my common denominator? 42. Does everyone see how I did that? Easiest way to get the denominators, I think, is just take the larger one and keep multiplying until you find a factor of the other one. You could do it with the factor tree. Students struggle with the factor tree. I think it's confusing for them. I think it's easier if you just use a calculator and work it out this way. But I've seen lots of instructors use the factor tree. That's not a bad thing, but I think this way is just easier and less confusing. So now we've gotten to this point. We're going to need to multiply everything now by our 42. And the numbers are going to be large, but that's okay, because we've got a calculator, and we'll be able to just easily and quickly multiply through by that 42. I think it's easier than working with the fractions. So now what do? Divide, multiply. So 42 divided by 7. Okay, well, 42 divided by 7, that's going to be a 6, right? 42 divided by 7, that gives you that 6. And 6 times 2 is going to make that now a what? 12. Bring down your x. Next one, 42 divided by that 14 down below. That's a 3, right? So that's going to be a 3 times 1. That makes it a 3x there. Next, 21. So 42 divided by 21, we know that's going to be a 2. And 2 times that 2 makes it a 4. And then do not forget the right-hand side. And that's going to be 42 times 38. And that comes out to be 1596. And that's okay because we have a calculator. We're not doing these by hand. We're using a calculator. So now we need to just work with this. So we're going to add all these together. These are the same. 12, 3, and 4. And 3 and 4 makes it 7. 7 plus 12 makes it a 19. Because 12 plus 3 plus 4, yep, that's going to come out to be your 19x here. And it should evenly divide by that 1596. And when we divide that out, that now comes out to be 84. So my answer for this one would be x equals 84. Now don't let the large numbers intimidate you. What do we do with fractions? If they're different, we just get rid of them. Students struggle with fractions. The faster we can get rid of them, usually the easier it is to solve the problem out. Okay, so that was number 7. We'll do a couple more, and then we'll do some more of these next week. So let's see if we can't get through most of these. Question 12 is next. Fractions again, same thing, just different numbers. They're all pretty much the same. Question 12 is 2/7 plus 3/14 x here plus 1 over 21x, and that equals 23. Now, we know the denominator, the least common denominator, since we did this a moment ago, is 42. So we're going to do the exact same process. A lot of times, it's repetition. It's the same, just different numbers. And so let's take our time. And finish it again. What do we do with these fractions? We divide and we multiply. So 42 divided by 7, 6. 6 times 2 makes it 12x. 42 divided by 14 makes it 3. 3 times the 3 on the top makes it 9. So that's going to be a 9x there. 42 divided by 21 is 2. Times 1 makes it the 2x there. And where students make a mistake is they forget about the right-hand side. So 42 times your 23, that's a 966. Add everything together, and let's see what we've got. So we've got 12 and 9 and 2. Okay, 9 and 2 is 11. And 11 plus the 12 should make it a 23. Okay, so we'll work with that. And then it should divide out evenly into that 966. So that's going to be a 23x equals 966. We'll divide by our 23. And that should come out, hopefully, to a nice whole number here. 966. Divide that by 23. That comes out to be 42. So very, very similar to the last one. Yeah, I think we'll try to do 2 more, and then we'll finish these up next time. So question 16. One over 11b equals a minus 4.22. When the problem has decimals, we can have our answer as a decimal. So we need to go ahead and get rid of this fraction. Well, we only have one fraction, and that fraction has an 11 below. So let's go ahead and get rid of that fraction by multiplying everything by 11. And let's see if that clears out our fraction. And I think it will. When we multiply through, the 11s, they cancel. 11 divided by 11 is 1. So that just makes it a 1b there. On the other side, what do we have? Well, we've got 11 times that 4.22. And that's going to be 46.42, and it's negative. Okay, so that's going to be a negative 46.42. Now, a lot of times, students try to take this further. How do I know that on a simple problem like this, how do I know that I'm done? A lot of times what happens is students try a problem like this and they think it's too easy. Because unlike the previous ones that took time, this one does not. So how do I know I can stop? I can stop because the variable is on the left by itself, the number's on the right. But I don't know how many times I've seen students encounter a question like this after doing one of the previous ones, and they get confused because it's too easy. And sometimes they are, just this simple. How do you know again when you're finished? Always take a moment to check that. Variable by itself on the left, numbers on the right, you know you're done. So that was 16. Let's look now at 17. The same type of problem. This one just has decimals only. We might actually be able to finish up the last two as well, because they're easy to work through. So we may be able to do 19 and 20 also, and finish up this section. So let's do question 17. And we have a minus 7.3 C equals minus 58.4. Okay. We don't have any fractions to worry about. We've got decimals. We use our calculator. We want to get the C by itself. That negative 7.3C, that relates 7.3, that negative, that relates to that C by multiplication. So we undo multiplication with division. So we're going to divide both sides by a negative 7.3. What do we know about our answer? Is our answer going to be a positive number or a negative? Positive. Why? Because a negative divided by a negative is a positive. Now we just simply, on the decimals, use our calculator. So we've got 58.4. We're going to divide that by 7.3. We know our answer is positive, so we don't even have to worry about the signs. And that comes out, and that gives us a final answer of C equals positive 8. And again, how do I know when to stop? Variables on the left, numbers on the right. That's what we wanted. That means we can stop. We've got two more, and I think we can get through these. And then we'll do questions out of 2, 3, and 4 next week. Because I want to make sure we have plenty of time for our test, and I want to make sure we have a good long break too. We can get up, walk around, and clear your mind if you need to. So question 19. 1 over 20, A equals 0. Well, where do we begin? Let's clear out the fraction. And we only have one fraction, and it has a 20 down below. So we're going to multiply everything by a 20. And 0 times any number is still 0. 0 absorbs other numbers. And we use 0 a lot in mathematics because it has that unique property of no matter what it's multiplied by, it becomes 0. So 20 times 0 is still 0. So now those 20s cancel out, and that leaves you then with an A. So now we've got our answer, which is A equals now what? 0. The 0 absorbs other numbers. And you'll find that in college algebra and in intermediate, we use 0 for a lot of different questions because 0 has that property of being able to absorb others. And 20 is very similar to the previous two. Looks a little bit different because instead of having a 1, we've got the n here. No different though when we go to solve it. We begin by clearing our fractions. So multiply it all by 2 there. And that's going to clear them out. So we're going to multiply everything by 2. And the 2's cancel. That leaves you with an n. And 2 times 10 makes it a 20. So that's what we've got so far there. So that's where we're at. We're going to now go ahead and take a short break. We'll do 2-3 and 2-4 next week. I just don't want to do too much. I want us to have plenty of time to take a little bit longer break and have plenty of time for your exam. So let's take about a 15-minute break. That we've got plenty of time to get up, walk around. Let's start our exam at, how about 9:50? So we're going to start our exam at 9:50. That should give you plenty of time to finish your exam. If you need a calculator, I'm going to bring in calculators. And don't forget you can have on your exam either a page of notes or note cards. So if you want to make up your notes real quick, you can do that. But here in about 15 minutes, we'll start our exam.